Alright, good day. As you can see, what we have today is transformations of exponential and logarithmic functions. Under this topic, we are going to treat three subtopics, which include transform graphs of exponential function, transform graphs of logarithmic function, and finally, write transformations of graphs of exponential and logarithmic function. So, if you are ready, I'm ready. Let's begin. The first is transform of graphs of exponential functions. So let me clean this one. So the first is transforming graphs of exponential function. What we have done in the past, it can be done in the same way we did in the previous chapters. We can say transform graphs of exponential functions as we have did for radical and rational exponent in the past, including quadratic and other functions we have treated. We can say do the same using the method we did in the past to transform the graphs of what exponential function. So let's begin. The first is for you to understand the table. Here is transformation. We have f of x, that is the notation we are using for the function. An example. So the first is horizontal translation. So if we are treating horizontal translation, when the graph translates horizontally from the parent's graph, the graph, in this case, the graph shift left or right, So in this case, for horizontal translation, the graph will shift left or what? Right. So the function that represents horizontal is of this type, f of x minus h. H is what the translation on the SI6. So if we have a new function, for example, g of x, let this g of x be a translation of this function f of x, which is usually the parent's function. So g of x is equals to 2 raised to power x minus 1. So if we have something like this, it means 1 unit, a translation of 1 unit to the right. Because of negative, if it's negative, to minus h equals to what? Minus 1. In this case, h is equals to 1. So it will move 1 unit to the right. So if we have g of x equals to 2 raised to power s plus 3. This is what we did in the past. So minus h is equals to plus 3. In this case, h is equals to minus 3. Therefore, it will move 3 units to the left. It will move 3 units to the what? Left. See, this is for what? Horizontal translation. Let's go for vertical translation. So next is vertical translation. All this we have did in the past for previous functions. They are the same. It's just I want to refer to the table for you to understand it, so we can go for examples. Vertical translation, we have graph. The graph will do what? The graph shift up or down. So the graph will shift up or what? Down. So in this case, we have f of x plus k. It can be plus, it can as well be minus. So when it's plus, for example, we have g of x is equals to 3 raised to power x plus 2. In this case, when it is plus. So when it is plus, what we have on, because of k plus, it will move up 2 units up. That will be 2 units up vertically. So what if we have g of x equals to 4 raised to power x minus 3. This 3 is not exponent, just minus 3. We have treated closed and open function. While the closed function perform horizontal translation left or right, while open function perform translation vertically up or down. So I have explained this concept, I have buttressed the point in previous lessons, and I believe that you are following up. So in this case, we have 3 units, 2 units down. So this is for vertical and horizontal translation. So let's go for reflection, or rather let's go for what? Horizontal stretch. Have any question? All right, let's proceed. So for horizontal stretch, or shrink, horizontal stretch or shrink graph, I hope you are following. The graph stretches away the graph will stretch away from, the graph stretches away from or shrink toward y-axis. So note this for horizontal what? Horizontal stretch. For horizontal stretch or shrink, graphs stretches away from or shrink toward y-axis. This is the point, towards what? Y-axis. So in this case, the function is of this type. It's always a closed function for horizontal. F of a x. So in this case, we have g of x is equals to the 7 exponential. This is 7 to the exponential of 3x. So with this, we have shrink. When it is this form, the graph will do what? The graph will shrink. So we have shrink by a factor of 1 over 3. So in this case, the graph will shrink by a factor of 1 over 3. To shrink by a factor of what? 1 over 3. So if it's of this type, g of x equals to 7 su over 3. It will stretch by to stretch by 3 unit factor. So if it is in this type, when the exponent is s over 3. In this case, a is a fraction. It will stretch by 3 unit factor. We have treated that for horizontal there is always a reciprocal when we are treating stretch and shrink in the previous lessons. If it is a whole number, it will shrink by one of that whole number, or 1 divided by the whatever it is. The same if it's a fraction, 1 divided by that fraction will give us a whole number, so it becomes a whole number. In that case, it will be a stretch by a 3 unit factor. So let's go for vertical. This table of value, you have to memorize them to enable you to solve problems involving all the properties of transformation of function. Vertical stretch or shrink. So vertical stretch or shrink, the graph stretches, or stretches away from, the graph will stretch away from or shrink towards x axis. The other one is y axis. This one is what? X axis. To stretch, the graph stretches away from or shrink towards x axis. So the function that represents it is of this form. A, that is the constant multiplied to the function. So we have g of x, for example, we have 3 multiplied to a function. So here it will stretch for vertical. The constant we represented it in that way. There is no reciprocal. We don't apply reciprocal in vertical. So g of x is 3 times 5 raised to power x. So it stretches by a factor of what? 3 unit. So it stretches by a factor of 3 unit. So what if it's g of x is of this form, 1 over 8 multiplied by 3 raised to power x? So what happened? So in this case, if it is of this type, what will happen? It will shrink by a factor of 1 over 8, to shrink by a factor of 1 over 8. So we have done horizontal translation, vertical translation, horizontal stretch and shrink, vertical stretch and shrink. So let's complete it with reflection, so that we go into examples of what we have to do. So the next is reflection. This table enables us to easily see what we are going to encounter in examples of transformation of exponential and logarithm function. So the next is reflection. So graph flips over x, or y-axis. So for reflection, the graph will flips over x or y-axis. The function that represents this is f of minus x. See, this is a close. For example, g of x is equals to 4 raised to power minus x. So this will occur in the, it will reflect in the what? Y-axis. It will reflect in the y-axis. Almost the reflection on the y-axis is a reflection to itself. We will not have any change. So for if it is the function, we have function of this type, negative f of x. So in this case, for example, we have g of x is equals to minus 4 raised to power x. So in this case, it will reflect in the s-axis. So this is the graphs, this is the table of values that way, table of value that will enable us transform graphs of exponential and logarithmic function. So if you don't have any question, let's proceed. So let's proceed. So the first is describe transformation. You are required to describe transformation of f represented by g, then graph each function. First of all, you are required to do what? Describe the transformation of f represented by g, then graph each function. So let's go. Describe the transformation of f represented by g, then graph each function. So what does it mean? Describe the transformation of f represented by g, then graph each function. The first is f of x is equals to 4 raised to power x. The transformation g of x is equals to 4 raised to power x minus 8. So the first thing is to notice that g of x is in the form in this form. G of x is equals to b raised to power ax plus or minus k. So notice that g of x, this function is in the form g of x equals to b raised to power ax plus or minus k. So we are in this case where a is equals to 1. If you look at here, our a is equals to 1. There is no change in the parent's function f with respect to g of s function here. There is no change. A is equals to 1 and k is equals to plus. K is equals to what? Minus 8. So this is the first thing you have to know. The next is to graph the function. Before we start going to graph the function, let us first describe the function. As we have told you, you are asked to describe the function. So let's describe g first before we can graph it. Therefore, the graph of g is a vertical translation by a factor 8 unit done. So the graph of g is a vertical translation by a factor of 8 unit done. The graph of what? Hope you are seeing in the graph of what? F. So this is the description you are required to state. So once we have stated it, the next is to do what? To graph the function. The graph of g is a vertical translation by a factor of 8 unit down because of minus of the graph of f. There's no other changes in the parents f of x with respect to g function. There's no other changes. So once we have stated this, the next thing is to do what? To graph the function. So let's clean here. So draw here vertical a Cartesian I6. Here is the y and here is x. Then choose a point here, 1. But before we start drawing, let us find some values of what? G of x that will enable us plot f of x, because we know that f of x, when x is equals to 0, f of 0 will give us what? 4 raised to power 0. That will give us 1. So that's why we get 1 here, 0 and 1. That means when s is 0, f of 0 is equals to 1. So we have 1 point here. And we have known that when the base that is of a exponential function is greater than 1, the curve will go like this. So we know that this is greater than 1, not a fraction. We put our curve here and draw a smooth line. So this is how it's going to look. S is the S-axis is the asymptote of f of x, because it's the parents. The S-axis is what? The asymptote, because at here k for f of x is equals to 0 plus k, because the function, like we have said before, the function is of this type. B raised to power ax plus or minus k. So for the parents, when k is equals to 0, we have only one function here, which is this. K is equals to 0. So it means that x is the Cartesian. The S-axis of the Cartesian is the asymptote of the parents. So, but as we proceed and definitely have a value for k, you will see that the asymptote for transformation of a new function is not always at the S-axis of the Cartesian. So having gotten the point for f of x, the next is to find point for g of x that will enable us plot the graph. So when I hope you are following, when s is equals to 0, because sometimes you may not be allowed to use a graphing calculator, you have to make use of the knowledge of what you learn on how to graph a function by using some values of x, substitute the values in the given function to find the values of the given function, and then use the table of value to plot the graph. So when s is equals to 0, we have what? G of 0 equals to 4 raised to power 0 minus 8. So this will give us what? Minus 7. For this we have one point. We have gotten 1 point at what? At 0 and the minus 7. I hope you are following. So let's get another point. So when the next is to do what? When s is equals to minus 1, let's choose minus 1. You can choose any point. When s is equals to minus 1, we have g of minus 1 equals to 4 raised to power minus 1 minus 8. So this will give us what? 1 over 4 is equal to 0.25. So 0.25 minus 8 will give us what? Minus 7.75. So we have another point, minus 1 minus 7.75. So we can use these 2 points, but let's see if we can get another point that will enable us. More points you get, more accuracy of the curve. So but let g of x, if g of x is equals to 0, what if this is equals to 0? So we can have here 0 equals to 4 raised to power s minus 8. 4 minus 8 crosses equal sign, we have 8 equals to what? 4 raised to power x. You solve the indices, this will give us 2 raised to power 3, 2 raised to power 2x. So if you solve the bases are the same, so what will happen? Base cancel out to give us what? If the base cancel out, have 3 equals to 2x. So divide both side by 2, we now have 3 over 2 is equals to x. So we get another point, we have 3 over 2 and 0. So these points will enable us to do what? Graph this function. Have any question? So let's proceed to so let's see if let s equals to 1. Let me get s equals to 1. More point, more accuracy of the curve. If s is equals to 1, we have g of 1 equals to 4 raised to power 1 minus 8. So this will give us what? Minus 4. Then we have already gotten all we needed to graph it. So the last point is what? When s is 1, our g of s is equals to minus 4. So from this we can now graph this function. I hope you are following. Okay, let's go. I have 1 here, we have minus 1. Our highest point is we have somewhere here. This is, I'm just choosing any point. In accuracy, you have to, for accuracy in your graphic paper, you have to choose a unit point, a different unit point of the Vatican and a different unit point for the SIZs, so that your graph will be accurately plotted. So so notice that here we have minus 8. So minus 8 here act as what? Act as our vertical asymptote, horizontal asymptote. We act as what? Horizontal asymptote. Which means there is no values of g of s that will exceed minus 8. So it acts as what? The horizontal asymptote. This occurs when g of x is equals to 0. If it is equals to 0, we have minus 8. So this minus 8 acts as what? Horizontal asymptote. Because of the shift of minus 8, it doesn't start from the parents again as k is equals to 0. No, it has start as when k is equals to minus 8. So the next is to when s is 0, y is minus 7. We have point here. When s is minus 1, y is equals to minus 7.5. Somewhere here in between. I hope you are seeing it. I draw a vertical here, I draw horizontal, so they will meet here. The next is when s is 3 over 2, that is 1.5. Let's say I have here 1 and I have here 1.5 and I have 2. So when s is 1.5, y is 0, it will occur here. And when s is 1, y is somewhere here 1.5. When this is 1, y is negative 4. So let's meet here. I hope you are seeing it. So from this, you can use a smooth a curve, join the point. It may not be accurate, but this is how the curve looks like. So this is how the curve, this is the curve. You see that here the minus 8 is acting as a horizontal asymptote. What do you understand about asymptote? Asymptote is a line that a curve approaches but never touch it or cross it. So this is g of x. So this is how you can graph the function of f of x equals to 4 raised to power 8, 4 raised to power x, e transformation g of x equals to 4 raised to power x minus 8. This is the graph. Do you have any question? So let's do more examples. The second example is if you are given 2 raised to power. The first example we did, what type of function can you associate with? That first example, that is f of x equals to 4 raised to power x and g of x equals to, you know that this all we are doing now is what? Exponential function, graphing exponential function. We haven't done, we'll still come to graphic, still come to logarithm. So if you look at this function, you will see that it's an open function. 4x is separate from minus 8. So the second example, we have the second example, f of x equals to 2 raised to power x. The transformation g of x is equals to 2 raised to power x minus 7. So you see this difference between the two functions, between the horizontal and the vertical. So this type of translation is what? This is horizontal. So see that this g of x is of this form. It is of this form, 2 raised to power ax minus 6. So in this form, you see that a here is equals to 1, which means there is no change in the parent's function with the g of x with respect to the parent function. Here we also know that minus h is equals to minus 7. In this case, h is equals to 7. H is equals to 7, which means it will move right. Because it's positive, it will go to right. So from here we can now describe the transformation as stated from the equation. So the graph of G is a horizontal translation. It's a horizontal translation by a factor of 7 units to the right of what? Of the graph of f. So this is what we are required to describe. The graph of G is a horizontal translation by a factor of 7 units. 7 is greater than 1, so it's going to be plural of 7 units to the right of the graph of f, by a factor of 7 units to the right of the graph of f. That is it. So the next is to do what? Is to find some points that we will use to plot the graph of f and g. So let's proceed. Let's draw our Cartesian I6. So from here, let's look for some point. This is y I6, this is x I6. Already we know that whenever x is equals to 0, f of x, the parents will be 2 raised to power 0. That will give us 1. It always started from 1. And because this is greater than 1, the base b is greater than 1, so it will be from here. Just take your curve, put it here, and then graph the function. To cross the SI6, to approach it, but will not cross it. So this is how it's going to look. This is a graph of f of x. So once we have done that, the next is to find some values for g of x. You may use a table of values. You may assign some point so you can plot it. So from here, let's say if you look at it, this is x. So what value can I put here to make g of x equals to 0, so I can get a precise point, the parents point that I will use to graph g of x. That will be when x is equals to 7. So that will make this equals to 0 or equal to 1. So g of 7 is equals to 2 raised to power 7 minus 7. That will give us 2 raised to power 7. That will give us 2 raised to power 0, which is equals to 1. So I have gotten 1 point for this, which is equals to 7 and 1. So the next is to when s is equals to 0, since I tried to make this equal to 0, g of s to find is 0 by putting 7. The next is, let me put s equals to 0. If s is equals to 0, we have g of 0 equals to 2 raised to power 0 minus 7. So this will give us 1 over 2. I hope you are seeing it. 2 raised to power 7. And this will give us 1 over 128. So these are 2 points I may like to use. Another one is 0 and 1 over 128. So when you get this, you can now plot the graph. So in this case, we have 7 here because we are told that it's moved 7 by our description of transformation of graph of g of x. It moves 7 units to the right. So from here, when it's 7, this is y is equals to 1. I can draw here. So they meet somewhere here. This is where they meet. So the next is when s is 0, s is 0 at this point, y is 1 over 128. Very little, some point here, unnoticeable, not exactly at the curve. Okay, let me make it a bit high. But if you look at the graph, it's very close to the line, so that we know that this is b2 is greater than 1. So if you put your curve, you can draw a line here, a curve, a smooth curve. This is how it's going to be. This means that so this is how it's going to look like. The curve so somewhere here. So going to look like this. This is g of x. So this is how the graph going to look like. Now merely looking at it, you see that if you try to define the range will be what? Y greater than 0. It is up. So that is how it's going to look, and the domain is all real numbers. Domain all real numbers, because it's from negative to positive. So all real numbers are numbers that can be represented in the number line. So all real numbers will satisfy it. So do you have any question? That is what we are required to solve. The asymptote is horizontal asymptote is when s is equals to 0. At that point, when s is equals to 0, horizontal asymptote. So that is it. When s is equals to 0, or rather when y is equals to 0, horizontal asymptote. Y is equals to 0 because it occurs here. So any question? This is the line of the asymptote. So let's continue. It occurs in the what? S-axis. And also s is equals to 0. So let's proceed, do some examples for more clarification. Do you have any question? It occurs in the what? S-axis. At that point, y is equals to 0, x is equals to, at the point of occurrence, y is equals to 0. Let's do some example more for clarification. So example 3, y is equals to 0 in the previous example for horizontal asymptote. So 3 is equals to question 3. This will give us 1 over 4 raised to power x. G of x, we have what? 1 over 4 raised to power x minus 3 plus 12. So how do you describe a transformation of g with respect to f, its parent function? So if you look at it, you see that this g is of this form. Ag of x is equals to b raised to power ax minus h plus or minus k. So in this case, where a in this case is equals to 1, there is no change. Minus ag is equals to minus 3. So in this case, ag is equals to 3. So it will move to the right. This is right. And in this case, k is equals to plus 12. So with this knowledge of what we have obtained, therefore we can conclude that the graph of g is a horizontal translation. So horizontal translation to the right by a factor of 3 units, and a vertical translation, of 12 units, vertical translation by a factor of 12 units up the graph of what? F. So the graph of G is a horizontal translation to the right by a factor of 3 units and a vertical translation by a factor of 12 units up the graph of F. So once we have stated the description, once we have described it, the next is do what? Graph it. So let's graph it. Always pause the video, go through what we did. Have question, text me or call me for clarification as you did in the past. So let's graph the function. This will give us 1 over 4, and g of x is equals to 1 over 4 to the power of s minus 3 plus 12. So let's graph it. So let's proceed. The first thing to do is to find some point to use to graph the function. Already we know that when x, the parents always started from 1, s is equals to 0, f of 0 is equals to 1 over 4 raised to power 0. That will give us 1. So the parents always start from 1 somewhere here. Here is 1. And because b is less than 1, it will start from here. The function will be like this. If it's a whole number, it will be like, it will go from the right to the left. But because it's less than 1, it will start from the right, from the left to the right. So put your curve. This is a graph of f of x. So this is the first thing to do. The next is to find some point of for g of x. So the easiest way is to look for a point that when s is equals to that that will clear the that will tend to make g of s equals to 0. That function is when that value of x is when x is equals to 3. That will enable us to find the base point that will give us a clue of how the graph is going to look like. So when s is equals to 0, we have g of 3. S is equals to 3. We have g of 3 equals to 1 over 4. 3 minus 3 plus 12. 3 minus 3 will give us 0. Any number raised to power 0 is equals to 1. So 1 plus 12 will give us 12. Will give us 13. 1 plus 12 will give us what? 13. So we have the first point 3 and what? 13. So this is the first point. The first point to graph the function g of x. So but when let's see again if g of x is equals to 13, it stays the same thing. So that is how we go into it. So let g of x equals to so do you have any question? What if g of x is equals to 0? This will give us a high mark. So we have gotten 1 point when 13. So let's see when g of x is equals to 12. When g of x is equals to 12, what will happen? We have 12 equals to 1 over 4 raised to power s minus 3 plus 12. So 12 coming to this side will give us 12 minus 12, and 12 minus 12 is equals to 0. This will be equal to 1 over 4 raised to power s minus 3. So this is the first thing. We know that any number 0 is the same thing as how do I put this? So 0 in this case there won't be any changes, because if it is equals to 0. No, let's yes, I think okay, let's go. So since 12 will act as here 12 will be as what? This 12 here will act as what? Horizontal asymptote for the g of x. Here is 12. To act as a horizontal asymptote, there's always a change. As long as it's not the parents, whatever changes in k will definitely affect where the curve will start. Will touches where the curve g of s will touches whether it's the vertical or the horizontal asymptote. So in this case we have one point here. We have a point here at 3, at 12, 13. So come to this point, join them, go down. Mind you, this is a vertical line. Join the two. So put your curve here. Draw a curve. This is how it's going to look. This is it. This 13 here, this point here only give us a point of turning where it turn, because at that point s is 3, 13 give us a point where it turns, and there's 12 as the intercept in the g of x, act as the horizontal asymptote. So we continue. So so do you have any question? Do you have any question? In this case, the 12 acting as the horizontal asymptote. In that case, horizontal asymptote y is equals to 12. It occur at y equals to 12. That is the horizontal asymptote for what g of x. Do you have any question? Range. The range is what? Y greater than 12. Y greater than 12, because see how it touches it, it didn't go down. So any value greater than 12 will satisfy the curve. So this is the graph of g of x. Since you don't have any question, let's proceed. We are still under what? Description, describing the transformation of f and then plotting the graph. So question 4. What if you are given f4 of x equals to what? 4 raised to power x. G of x is equals to 4 to the power of 0.5x 0.5x minus 5. So this is what we are given to describe and plot and plot the graph. First thing is to notice that g of x is of this form. So this form, b raised to power ax minus h. Mind you, h here is not the function itself, because this function can be anything like z. I can use any number. Z of x is equals to b raised to power as minus h. H here is a translation on the horizontal axis. So from here we have where a is equals to what? 0.5. Notice 0.5, there is a change here. This change is horizontal, has to do with the stretches for horizontal and the s axis. So this is the same as 1/2. Is it not? 1/2 give us is equals to 0.5. So we have h to be equals to, because minus h is equals to minus 5. So h is equals to 5, which means it will move right. To go this way, not this way. And we also have b to be equal to 4. B is equals to 4. There is no change in the parents base and the g of x. So with the information we have, we can now conclude the graph. The graph of g is a horizontal translation by a factor of 5 units to the right. So horizontal translation by a factor of 5 units to the right, and a stretch and a stretch. Why is it a stretch? For horizontal. If you look at this, we are talking of horizontal. Everything here is based on horizontal. If there is any constant here, we must translate that constant as stretch or shrink in the vertical axis. But for this type, this is for horizontal, and we know that for horizontal, there is always a reciprocal application. That is, when we are talking of the changes, a will be equals to 1 divided by 1 over 2. That will give us 2, and 2 is a stretch, it's a whole number. What if here is this place is maybe 2, not 0.5? Here will be 2. 1 divided by 2. That will give us 1 over 2. It will be what? It will be shrink. So, but we are not discussing about shrink, we are discussing about what? Stress. So our A is equals to 2. And a stretch and a horizontal stretch I hope you are following. Horizontal stretch of 2 units. Horizontal stretch of 2 units of the graph of f. So this is the description. The graph of G is a horizontal translation by a factor of 5 units to the right, and a horizontal stretch of 2 units of the graph of f. So once we have stated your description, the next is to graph the function. So let's go into graphing the function. Once you draw the s and y axes, you have to choose point. So we know already, we know it always started from 1. Let's choose 1 here. We can now graph it. Base is greater than, it's not a fraction, it's a whole number. So it will start from here. So this is how it's going to look. This is a graph of f of x. So the next is to graph g of x. Looking at this, we can write this as here we can write g of x to be 4 raised to power s over 2 minus 5, because 0.5 is equals to half. So notice that s is, the first thing is to do is, what value of s should I put here so that this will give us a minimum, a base point that we can use. If we put 0 here, this will not, it will give us when we put 0, you'll be having something like okay, let's say s equals to 0. If you put 0 here, you have g of 0 equals to 4 raised to power minus 5. This will be giving us 1 over 4 raised to power 5. A very fractional number, close somewhere here. Very fractional. It's insignificant. Because 4 raised to power 5, if you do it, we'll be having something like 0.00, something significant somewhere here. Close to the line. It doesn't mean it touches the line. Very, very close. It won't touch the line, very close somewhere here. So it won't give us a clue of how the curve will look like. So we need something that will give us a clue how the curve will look like, that will make g of x close to 1, not close to 0. So to do that, let s equals to 10. When s is equals to 10, you have g of 10, have 4 raised to power 10 divided by 2 minus 5. So this will give us 4 raised to power 5 minus 5. and that will give us 4 raised to power 0. I hope you are seeing it. 4 raised to power 0 is equals to 1. So this is a good point that we can use. In this case, we have 10 and the word 1. Mind you, after your description of a translation, that is G translation, in as long as there is any changes in the parents function, a movement of G with respect to the parents doesn't really started from 5 because of this stretch or maybe string that attached to the parents. That values, if you use a table of value, will definitely affect changes not exactly at 5. You see that either it moves a bit beyond 5 or it goes down beyond 5. Either it moves to the right a bit or before 5. That's why it's always good to choose point to graph, make use of the knowledge you learn during graphing a function to plot there, and to use some point and graph any given function given to you without just a transformation always will tell you where the graph will base, exactly where it goes. So with that, you can now apply the knowledge of graphing function to exactly graph any function given to you. That is my own explanation. So we have gotten 1 point, 10 and 1. So you notice that when x is equals to 5, s is equals to 5. If s is equals to 5, we have g of 5. That will give us 4. 0.5 times 5 minus 5. If you do the calculation, you having 0.0, this is approximation, 0.03125, which is telling you that any number less than 10 for x will always give you a very fractional value of the g. So you must always look for a number that is greater than 10 so that you see a significant changes in the curve. So let's plot this graph. When s is 5, y is 0.03125. So let's use these 2 points we got to graph the function. The next is when s is, we have 1 here, we have 0.01, so I can choose somewhere here 0.03125 or whatever, as we have seen. We have another point here 5, and we have 10 here, 0.023125. So draw a line, a vertical line here for this one. When it is 1, you draw another one. I hope you are following. You draw another one here, and the one we have here, a very significant, when what will I say, when s is equals to 0, very significant figure here. That is when s is equals to 0, we have 1 over 4 raised to power 5 somewhere here. So use your smooth curve, put it here, join, put it here and join. So this is how it's going to look. You know, this is a sketch. So this is how it's going to look. Please, this is how it's going to look. Alright, this is a g of x. Do you have any question before we proceed? That is but there is some observation you have to see. We say that if you move 5 units to the 5 units to the right, and then horizontal stretch by 2 units. If you notice, because this is a 0.5, notice that when if r is equals to 1, our r in this case, okay, let's say, notice that if a is equals to 1, a is equals to 1, if a is equals to 1, that is g of x equals to 4 raised to the power s minus 5. The curve will start exactly here. It will start exactly from here, somewhere here, because we are told is 5 units to the right. It starts here, but because of 0.5, there is an adjustment. It doesn't start here exactly. But if a is equals to 1, in this case, it will start from 5. So you have to note this. Changes in the function of a given parent also affect how the graphs going to look like. That's why I say you have to make knowledge of what we learn in graphing functions and apply it in this exponential and logarithm function, graphing of exponential and logarithm function. Do you have any question? All right, let's continue. So we are still under description and the description or translation of what? Of the parent's graph, and then we graph it. So the 50th example in this case, we have f4 of x equals to e raised to the power minus x. G of x is equals to e raised to the power minus 5x plus 12. So you are given this to graph. Notice that g of x is of this form. Let me use another function in this case. You can use z. Equals to, is of this form, e raised to the power ax plus k. Is it not? It's of this form. So where a is equals to, from what we see here, a is equals to minus 5, k is equals to 12. So once you state this, you can now conclude that therefore the graph of g is what? It's a horizontal shrink, because of it is attached here. It is maybe 5 is here, it will be vertical, but because we are still talking of what? A closed function. This is a closed function of natural base e. So the graph of g is a horizontal shrink. Note that a is equals to this, but actually our a in our own translation is a equals to what? 1 divided by what? Mind you, this a plus this negative sign, even though the difference is is in the other side, so it's also, this will be in the other side. It will start from the negative si6. So our a in this case is 1 divided by 5. That will give us 1 over 5. So therefore it will be a shrink, because we are talking of a closed function. The graph of g is a horizontal shrink. Horizontal shrink by a factor of what? So it's horizontal shrink by a factor of 1 over 5. So you write 1 over 5. Horizontal shrink by a factor of 1 over 5 and a vertical translation by a factor of 12 units of the graph of f. So once you state it, you have already described the translation. The translation of f. The graph of G is a horizontal shrink. Okay, let's the graph of G is horizontal. It's a horizontal shrink by a factor of 1 over 5 and a vertical translation by a factor of 12 units of the graph of f. So, having known how the description, the next is to do what? To graph the function. Have any question before we proceed? If you don't have any question, I assume you understand it, so we can proceed to the next. The graph of G is horizontal what? Shrink by a factor of 1 over 5 and a vertical translation by what? By a factor of what? 12 units of the graph of what? F. Alright, let's graph it. Let's graph the function. So draw your vertical Cartesian I6. Here is y, here is x. So well, first, if you're looking at this f, when s is equals to 0, we have already done this several times. S is equals to 0, f of 0 is equals to e raised to power 0. E raised to power 0 is equals to 1. So it will start from 1. It will start from here. And because we say that if a given function f of x of 1 is equals to e raised to power maybe irx, this is the parent's function. So when a is equals to 1, a is equals to 1, r is equals to 1, we have f of 1 is equals to what? E raised to power what? X, which means it will start from here. The graph will start from here. All I'm trying to explain to you is if r is greater than 0, if r is greater than 0 and a is greater than 0, in that case it will start from here. But if r is less than 0 and a is greater than 0, it will start from here. I hope you are seeing it. In this case, our r is equals to minus 1. That's why we get negative here. So the graph will start here. That's why we have e raised to power minus x as in this function. It will start from here because r is less than 0. Refer to what we did in exponential for natural logarithm, base e. So you see how the graph started when r is less than 0. So in this case, put your curve here and draw it. And we didn't we are not told that it's coming up, so it will look like this. Sorry. So this is a function f of x. This is the first thing. The parents is always easy to graph. So the next is to consider this function. Mind you, sorry, this is 2. So be aware of my description. Not 12. That's supposed to be 2. So refer to our description. Wherever you see 12, know that it's 2. The graph of G is a horizontal shrink by a factor of 1 over 5, and vertical translation by a unit of 2 unit vertical. So that we'll be able to, even if it's 12, even if I leave it at 12, which means there will be a little, okay, let me leave it at 12, so that it will be considered very well. So in this case, if it is 12, which means when s is equals to, s is equals to 0, z of 0 is equals to e raised to power 0 plus 12. We have what? 13. So 13 here will be our point of turning. I can choose here. Mind you, this is not drawn to scale. Here is 12. Here is 13. So our 13, when in this case, when 0 and 13, when s is 0, g of s is 13. So somewhere here. So 12 will act as our what? As our horizontal asymptote. 12 will act as a horizontal asymptote. So because of this 12, you now draw a line here. There will be any values of g of s that will be less than 12. That's why 12 acts as what? Horizontal asymptote. So with this, you put your curve here and graph it. So this is how it's going to look like. So this is g of x. So once you have done that, that is how it will look. 12 acts as what? Horizontal asymptote. 12 acts as horizontal asymptote. In this case, y is equals to 12. Our horizontal asymptote. Horizontal asymptote, y is equals to 12. At here, k is equals to 0. So that the base of the parents function, the s axis of the Cartesian axis will act as the what? The asymptote for the parents function, as we have seen here. This one acts as the value at this point. Y is equals to 0 for the horizontal asymptote. So, but at this point, for this type of function here, y is equals to 0. Sorry, for the horizontal asymptote. But for here, because there is adjustment of 12, asymptote is what? Y is equals to 12, and the range is y greater than what? If you do this one, range, I hope you are following. Y is greater than 12, and the what? Domain will be all real numbers So the main all real numbers will satisfy the function. Have any question? There's no question, so let's proceed. If you see, we have been doing some examples. I think let me do one more examples, then we'll go to what we have next. All the examples we did is sufficient for you to graph any function you come in contact that involve exponential function. So the next is the last is example 6. If you are given f of x is equals to 3 over 4 raised to power x, and g of x is equals to minus in bracket 3 over 4 all to the power of s minus 7 plus 1. So you are asked to describe the transformation and graph the functions. So notice that g of x is in this form. g of x is equals to, let me use capital letter, it's in this form: a b raised to power s r minus h plus or minus k. So it is in this form. So where a is equals to what? Look at it here. This is minus 1, and that is a reflection. Reflection in the S axis. Refer to the table of value for transformation. So reflection in the S axis. We also have r is equals to 1. It is constant. If you look at it, r is equals to 1. It's constant between the parents and the g of s. There's no changes. So no changes. We have h. In this case, the first thing is to know that minus h, as here, is equals to what? Minus 7. So which means h is equals to 7. That is right. So the next is k. K is equals to 1 plus 1. That will give us it move up. So once you have already know all of this, therefore you can now describe the translation. So therefore, this is therefore the graph of g is a horizontal translation. It's a horizontal translation. It's a horizontal translation by a factor of 7 units. By a factor of 7 units. Look at it, 7 units horizontal. Look at here, 7 units, and vertical translation I hope you are seeing it. And a vertical translation by a factor of 1 unit. By a factor of 1 unit. A vertical translation by a factor of 1 unit. Look at it here. And a reflection in the S axis of the graph of f. So this is what we are required to describe. The graph of G is a horizontal translation by a factor of 7 units, a vertical translation by a factor of 1 unit, and a reflection in the s-axis of the graph of f. Once you have described it, the next is to do what? The next is to plot the graph. So I can clean the board. You can pause the video, go through it. If you have any question, please ask. So let us graph it. First thing is to draw the Cartesian axis. So from here you put y, here you put x. First is to choose some point to enable you do this. Let's choose some point for g of x. For g of, so the first is when x is equals to 7. When s is equals to 7, if we put 7 here, we have g of 7 is equals to minus 3 over 4. 7 minus 7 plus 1. So this will give us what? Minus 1 plus 1. That will give us 0. So this is the first point you will choose for yourself. So this will give us 7 and 0. This is the first point. The next is to get the second point. When s is 0, if we put 0 here, we have g of 0 equals to minus 3 over 4 to the power of 0 minus 7 plus 1. So use your calculator to find this value. You see this value is approximately for g of x. This is approximately negative 6.49. You see that this is approximately negative 6.49. This is to 2 decimal places. So we have another point, 0 and negative 6.49. This point will enable us graph the function. Have any question? So alright, let's get one more point for x. You can choose as many points as possible. The more point, more accuracy of the graph. So let s equals to 1. When x is equals to, s is equals to minus 1. If s is equals to minus 1, have g of minus 1. This will give us minus in bracket 3 over 4. Minus 1 minus 7. Minus 1 minus 7 will give us minus 8. So you can write it immediately. Minus 8 plus 1. Use your calculator or four-figure table to find this value. So this will be approximately minus 8.99. So you bring the point here, minus 1 minus 8.99. So we have already gotten 3 points. So with these 3 points we can go into graphing it, or if you like you can still choose one. So with these 3 points is enough for us to graph it. So for the parents, it's always started from 1. We know this. Let's here be 1. So we can graph this. This is half. B less than 1. So the graph will start from here. b is less than 1, if it's a whole number, it will start from here. We have said this several times. So we put here curve here. This is how it's going to look like. This is f of x. So the next is minus, because it's a reflection. We'll be looking at somewhere here. Let's choose some point. Let's here be somewhere here, minus 6.49. Here will be what? Minus 8.99. And then let's here be minus 1, minus 2. Have 1 here until we get to a point here. Here is 7. So we know that when y is 0, s is 7. So we have point here. That's told us that there is a point we can get from here. The next is when s is 0, y is negative 6.49. We have another point here. And when s is minus 1, y is negative 8 point. So you draw a horizontal line here until you get to negative somewhere here. Get to this point. This is negative 8.99. Negative. So this is where they meet. So with your curve, smooth curve, you will join. This is how it's going to look. Sorry, this is how it's going to look. Hope you've seen it. That is all you are required to do. So this is the curve. In this case, the knowledge of plotting a function already enable you know that not exactly it will come from 1. So some will say because of 1 here, and this is reflection, you put somewhere here and draw. No, not exactly. You may have to apply the knowledge of plotting of graph, because why is it not from 1? There is changes also in the parents function. It's minus 7 also affected the location, so it will move a bit, not starting from 1, because if you choose point for x, as you choose point for here, you choose point for x, you see they have different point or values of g of x. That's why the graph looks like this, or the graph is in this form. So I believe that you already learned how to graph and describe any given function, possible the one we are doing now, exponential. So with that knowledge, do these examples, do this homework. The first is f of x is equals to 1 over 3. f of x is equals to 1 over 3, and g of x, this is comma, g of x is equals to 1 over 3 to the power of x plus 2. I hope you are seeing it. There is minus here, minus 2 over 3. So the first one is this. The second is f of x is equals to 2 raised to power x. G of x is equals to minus 2. This is minus 2 to the power of x minus 3. So this is the second one. The third is We have f of x. The ones I gave you the previous homework, you never submitted it to me. G of x. This is equals to 4 over 3 e raised to power x. So I hope you are seeing them. Please do this and present them to me. Always pause the video, go through what we did. Have any question, please endeavor to ask for clarification. So the last one is do this one. 4 questions come from this because of we did many examples. F of x is equals to e raised to power minus x. G of x is equals to 3 e raised to power minus 6x. So do this assignment and submit them to me. The next we have is we are going to transform graphs of the logarithm functions. But for now, this is where we stop today. If you have any question, send your questions to me through WhatsApp, call me, or even go to our website and drop some your question to the contact box. Exactly, it will come to me. So see you in the next lesson. Bye for now.